Everyone, and welcome back to the channel. So this is Expert Funder and you're watching on the YouTube. So today we are diving into a interesting number theory and string problem that's often we can see in the interview, and it's a good digit strings. And let's stick around, and because the solution involves very clear in the math tricks, and yes, we'll go with the Java code writing. And so here is the problem that you can see, right? So the problem statement is saying it's a Leetcode 1922. So we have to count good numbers, right? So what is a good numbers in the sense of the problem, right? So the statement is saying digit string is good if the digits, that is a zero indexed at even indices, are even, and the digits at odd indices are prime. 2 3 5 7. For example, we have given 2582 is a good because digits 2 and 8 are at even positions, and digit 5 and 2 are at odd positions, which are prime. However, 3 to 4 5 is not a good because 3 at index at an even index, but it not at the even, right? Like that he's saying. So we have to give an integer n, right? Sorry, we have to return a total number of good digits string of length. Since the answer may be large, we'll take a modulo. And so what is a digit string? It's a consist of 0 to 9 digit, right? And it may contains leading zeros also. So you have a couple of example here. So better you'll pause this program, right? You pause here the video and go through the examples and the statement is saying. You will clearly understand what is this thing is here, right? Okay, so let's look at the example. So question is saying if the input have n equal to 1, right? And so output is coming 5. Why? Because the good numbers of a length 1, that is n equal to 1, are 0 2 4 6 8, right? These are the possibilities that we have, and so the output are 5, right? Means if n equal to 1, then only index 0 needs to be even. So the options are 0 2 4 6 8, and that's a 5 good string, you can say. And so the output is coming 5. If you'll talk about n equal to 2, right? Just think about it, then you will understand the example. Further example you will understand. Okay, so I have created a table here, so you will understand clearly. So if n equal to 2, index 0 is even, right? Index 0 is even, then there will be 5 choices. Index 1 is prime, right? And there is 4 choices. So total how many it will become? N into n, right? So it will become 20. Okay, so see, let's suppose you have a digit, right? You have a digit n equal to 1. How many even indices is there? Only one, 0, because in the program we used to start index 0 to n, right? So how many even indices is 0? If you'll talk about the even count, then how many counts are there? Because it is 0, at 0 there will be some element, right? And that element will be anything, right? Like options will be 0 2 4 6 8, right? Anything. So count, how many even count is 1. Okay, if you'll talk about the odd counts, there will not be odd counts, right? And so the odd count is 0, right? That is a possibility. We'll go with the 2, and similarly indices can be either it will 0 or it can be odd, right? So 0 is not possible. Sorry, 0 is not possible. In this case, odd is there, right? If we talk about 3, then there will be 3 indexes, right? 0 to 2, right? So there will be even is 0 2, odd is only 1 at 1. Like that you can see. If total element are 4, right? There will be 2 in even indices, 0 and 2. If you talk about the odd indices, it will be 1 and 3. So how many counts are there? 2 2, right? Similarly, if you'll go with the 4 for altogether 5, right? There will be 3 even count, 3 even index, 0 to 4, and for odd 1 3. So like that I'm saying to go with. Okay, so if anybody is saying n equal to 4, let's for example we are going for example to n is 4, right? So if n is 4, even index is 2, so total even count is 2. Here you can say odd count is 2, right? But index 0 is even. Index 0 is even. So there is, how many choices are there? 5 choices are there. Index 1 is prime, so there will be 4 choices, right? Like that, if you find, there will be total how many choices are there? 5 into 4, right? And so it will become how many? 20. So simple so far, right? So don't we get confused. You have to think about the possibility, right? Okay, so we'll talk it about more. Okay, we'll talk it more about it, so don't worry. So let's understand what is the trick here. So here is the trick. Instead of generating all the digits string, which would be super slow, we just count the possibilities. Okay, this is the purpose. So let's suppose if all even positions are there, right? If all are even position, just think about it. So there will be 5 choices, right? If all are even. So I'm talking about this last. Okay, so if all are even, okay, so how many choices are there? 5 choices are there. 0 2 4 6 8, right? 5 choices. And if you'll talk about the odd one, then how many choices are there? Can we say 9? No, right? 9 can be divided by what? 3. So we can remove it. Can we remove it? For the indices it will be there, but the choices will be how many? 4 will be there, right? So I'm saying don't get confused the indices, right? The choices are different, right? So there will be 5 choices, right, for the even position, and odd choices will be 4 choices, right? We'll talk about this more. So if n is 10, so even index count will be n plus 1 by 2. So total how many it is coming? 5 is coming. So if you talk about the what we can say odd index, right? There will be also 5 will be there, right? So total n equal to 10 is 5 to the power 5 into 5 to the 4 to the power 5, right? Because there is 5 and there is 5. So choices are 5, so 5 to the power 5, and choices are for this is 4 to the power 5, right? So total how many will be there? Just we have to multiply it, whatever the data is coming, it is that, right? So it become exponential, it is coming, right? And so it is saying to make it modulus, we can get the modulus of this. I think you are understanding, right? So you just think and understand, right? So if this is the case is happening, let's suppose 10 to the power 15. What if n equal to 10 to the power 15, right? So you can't calculate such huge numbers. You cannot calculate the huge numbers, but what you can do, we can generate the fast exponential values. So well, let's understand another example where we will use modulus exponential, that we will compute base to the power exponential, and this will become what? How many? We have to take the modulus, right, for that, so that we will get the efficiency in the log time, and so it will avoid the overflow and it will keep performing the performance. Okay, so we'll go through the Java code here. So in the first step, I have written the compute the counts. So in the computing the counts, we have to count first even count n plus 1 by 2, and it will give for all the positions, right? What are the positions are there? 0 to 4 6 8, right? These are the even counts, right? And for the odd counts, we have to calculate n by 2, and so we'll get the all the positions counts here, right? And so if we'll calculate this, all counts will come even and odd, like it will come 5 here and it will come 4 here, right? You have to just calculate how many counts will be there, right? 5. Now we will go with the calculating the power using the fast exponential. So for that we have to take the power of count. So we'll pass power and count. So the function is here the power x and y, right? So x will be the value that we have the choice, so we will use 5. And for the even count, how many values are coming, right? So based on the value it will come the counts, right? What is the count? It all depends on n, what is the input of n, right? So even count in this case is coming 5, and for the 4 it is coming the 5, right? So 5 to the power 5 and 4 to the power 5, whatever data is coming we have to multiply it, and then we have to take the mode in the step 3. You understand what I'm trying to say? So I'm trying to say, if we have the long value, right? Let's suppose 10. Okay, so n value is coming how many? So, sorry, even count and odd count, you can see 5 is coming, but but uh, but the power is the 5 and 4. From where it is coming 5 and 4 here? Because we are taking the power, right? So for the even count we have 5 choices, and for the odd count we have 4 choices. So 5 to the power 5 and 4 to the power 5 is coming, right? So that we have to multiply, and we have to return it, right? And then we have to take modulus. If we will not take the modulus, it will not return the exact answer that we required here on the Leetcode, right? So to understand the exponential problem, right? First we will take the base and take the exponential value, right? Then we'll take the result, and this result will get return. But for that we have to take the mod. We have to use this formula, right, where we have to take exponential is greater than 0. If it is greater than 0, then we will take we have to take the base, right, and then we will return it. Otherwise we have to get the base again, and we have to pass the shift, and we have to divide actually by 2, and then we will return. I think you know this. If you don't know this, please bring me in the comment box, I'll explain. I think video is already too long. So thank you guys, thank you for watching this video. If you have any doubt in this video, so you can ping me in the comment box. And if you have any query regarding the DSA learning, or if you want any training classes, please ping in the comment box. Also let me know the time complexity in the comment box. Thank you for watching this video.